Large language model is a statistical system trained to predict the next unit of text in a sequence. It operates autoregressively. It generates output one unit at a time, each conditioned on all preceding text. The unit of prediction is the token, a fragment of text averaging roughly 3/4 of an English word. Hamburger may tokenize as hamburger. Origin of capability. An LLM's competence derives from scale across two dimensions: the corpus of training text, a substantial portion of the public internet, and the count of parameters, internal numerical weights, frequently in the tens of hundreds of billions, that encode the statistical structure of language. GPT-3 around 175 billion. Open weight families such as Llama 7 to 70 billion. Please note, ChatGPT-3 was here, what, a year ago, half a year ago? So now it's 5.5. Information is not disclosed. We do not know how many parameters or weights are there in those systems officially, but it's more than this number. Formally, the trained model approximates a probability distribution over token sequences. Informally, it is a lossy compression of human-authored text into a function that recombines that knowledge on demand. Training. Training of LLMs happens over a long period of time and requires grids of electricity being transferred from, for example, housing, electricity for the housing, towards training of the LLM models. Usually they are containing two steps. One is pre-training. Pre-training is then feed all the available data into the model with an expectation that it will possibly do what you want, because it is based on a transformer methodology that they have figured out should work. A transformer methodology has been introduced a little MIT, I think, or Google researchers, 2017 paper, when the idea there is that previously there was already prediction mechanism, and they were pretty successful, but like T9, for example, on your phone, Nokia phones. Remember, T9 is a predecessor of LLMs, let's say, predict next text based on what was the previous part of the word, let's say. Now, transformer methodology, there were other ways for LLMs to work. Like, it all, again, boils down to math, to algorithms, to an ability of science to come up with ways to congregate data in more advanced ways than it was before. So this transformer methodology, the concept there is that in a sentence, each word is mapped to each other. I think there will be a little example over there. So the idea there is that when you pre-train the model, all the data that goes in, it becomes a large corpus of data that is congested, like, okay, transformer, look, transformer architecture. So I'm not a scientist. What impresses me here is the amount of operations that run within a model when we wanted to give us an answer. This is what happens within an LLM. We have a word or a sentence that is being split into tokens. Each token receives its embeddings. Embeddings is an address of the word of a token within the LLM database. This is how approximately it would look inside. So the words would be positioned within different clusters within that bucket, let's call it. And that bucket would have words that are similar in meaning close to each other, and then the words that are different in meaning would be separate, further from each other. And the idea is that all the text that you have becomes a pre-trained methodology where everything that has been put into that LLM now can be retrieved as a prediction algorithm. If we talk about it from the perspective of the data that has been combined in the LLM, all the knowledge that has been put into ChatGPT, for example, during the pre-trained model, the weights are these elements that are connecting the words in between the nodes. When we talk about LLMs, for example, when we requested the information it speeds the prediction algorithm works through the parameters that are set with with numerical values, and those values we do not know necessarily how that LLM structures those parameters. So when we send a request to LLM, the pre-training model just congests all the data, and that requires a lot of electricity. Now, when we have all the data within the LLM, not necessarily it would answer the way that we want. It requires a second step that's called fine-tuning. And fine-tuning requires scientists like ChatGPT, the original model that was trained. It required thousands of people who sat down and asked questions to an LLM, and then LLM would respond, and then the people would say, okay, this is correct answer, or this is incorrect answer. And that would tell the LLM if it's doing the right job. Now, the hallucinations as a part of it also derives from that bias, because the most important piece that LLM is supposed to do is to provide an answer. If LLM didn't provide an answer, it would be told, okay, this is wrong because you did not provide an answer. So by default, each LLM is trying to give anything just in order to respond to you at least anything. So after it responds to you, it doesn't necessarily even care if the answer was correct. That would be the fine-tuning part. And guardrails that we put on it at a later stage. But the fine-tuning part is also the part that differentiates the frontier models from the, let's say, Chinese models or models that Russians are developing. ChatGPT spends billions of dollars on fine-tuning their models. They ingested the data, then they fine-tuned that data. And the idea there is that, or other LLMs from and then there is another, DeepSeek. What they did is they sent API requests to ChatGPT database, received the answers that they wanted, and trained their own model to answer based on ChatGPT responses. So the idea here is that so they automated the process pretty much. So they instead of hiring thousands of scientists, they sent requests back and forth between their LLM via API and ChatGPT LLM, fine-tuning their model.